Howdy, 8th grade. Today we're going to talk about one of my very favorite things to do here in mathematics, which is going to be factoring trinomials. And it's a little bit different from the factoring we've done before, but it's also a little bit the same. So we're going to do a little bit of build up till we actually get to factoring trinomials so we can get there. So the first thing I want to talk about is just factoring right here. So what we've seen for factoring before would be I'd have let's do 9x squared plus 12x. If I factor these, not 112x, just 12x. If I factor these, I would end up getting 9 times x squared. 9 goes to 3 and 3. X squared goes to x and x. And my 12x becomes 12 and x. 12 becomes 3 and 4. So as I go through here and factor this, I can see that from my two different squares here, that's a little dark. For my two different squares, I've got a 3 in both, and I've also got an x in both. So I can take out that 3 and that x and put it outside of a parentheses. And my goal here is to make something for the distributive property. So 3x times what would give me 9x squared? That's pretty easy. Just take what's left in here, which would be 3 and x, plus 3x times what is 12x would be 4. And just like that, I have factored 9x squared plus 12x. Ta-da! Pretty easy. But sometimes we'll get some things that are a little bit more complicated, and that's where trinomials are going to come in. So when we see trinomials, what I hope, and I am recording this all in pink at the request of Abby, this is going to be a little bit more of a purplish pink. Factoring trinomials, when we hear trinomials, I hope we think of monomials and tri. So tri, of course, means 3. So we have 3 monomials, and a monomial is just a bunch of stuff multiplied together. When we're talking trinomials, what it's going to look like is going to be ax squared plus bx plus c. And this is what we're going to try to factor. And this is going to have a ton of uses in a few lessons here. Right now, it's just going to be kind of factoring for the sake of factoring, but that's okay because it's fun anyways. So what we're going to try to do is to factor this out. And I want to show you guys a quick example for what we can do here. So we're going to start with x squared plus 3x plus 2. And I want to find a way to factor this. So if I go through this, I could do my 3 factor trees, and I'd end up with an x and an x, and a 3 and an x, and a 2. And I do see that these x's are in common, but there's no x here. That doesn't exist. It's not a thing. So what that means is we can't factor this the way we used to. But I still want to try to factor it, and to factor it, I need to make something that would multiply to something else to end up with this right here. So just kind of something we've done before is foiling. So foiling, of course, is going to be first, outer, inner, and last. And what we're going to do when we factor a trinomial, so factoring trinomials, that is going to be foiling backwards. I'm just going to write back because I don't think I have enough room to write backwards there. That's okay, so we're going to FOIL backwards. So we know that our answer for this should end up being this square right here. So if I want to end up with that square right here, I know that my FOIL has to end up with that. So let's look at some possible options. So I'm going to start off with 2 different sets of parentheses, and I know that they're going to be 2 sets of addition, because if I have 2 different binomials, I can multiply them together with FOIL, and I want to end up with x squared plus 3x plus 2. The first thing I want to do, it'll make our lives a lot easier if we just put an x in the front of both. I'm going to kind of cheat and let you guys know that most of the time you're just going to have an x at the beginning of both of these, and that's going to make our lives a lot easier from there. So I have x plus something equals x plus something, which is kind of obnoxious, but that's okay. So x plus something times x plus something has to equal x squared plus 3x plus 2. So let's FOIL this, and see what we get. I'm just going to put, we've already used A, B, and C this video, so I'm going to use D and E now. If I FOIL this, my first is x and x. I get x squared. O would be outer, would be x times E. I would be inner, which would be D times E. Sorry, not D times E. X times D. Let me fix that. X times D. And L would be last, which is E times D. So what that means is we multiply this out, and I get that this is equal to x squared plus x times E plus x times D plus E times D. I'm going to simplify this a little bit more. So this is going to be equal to x squared plus, and I can factor these two terms here, and what happens then is it gives me D plus E times x. So I just did that the old way of factoring, where I took the x out of both and put it on the outside of the parentheses, and we were left with E plus D. So you have x squared plus D plus EX. Let me get rid of all those extra lines. D plus EX plus E times D. And what I want to end up with is x squared plus 3x plus 2 right here. So equals x squared plus 3x plus 2. So what I have now is that I need to find two numbers, D and E, that add to 3. So I want it to add to 3. And E times D has to equal 2. So they must multiply to 2. So we should be thinking right now, what are some numbers that are going to add to 3 and multiply to 2? Add to 3, multiply to 2. And so I'm just going to start thinking, well, what can I do to multiply to 2? The only one that comes right off the top of my head would be 1 times 2. And thankfully, 1 plus 2 is going to give me 3. So my two numbers are going to be 1 and 2. And so if I factor this, I can say that x squared plus 3x plus 2 is going to be equal to x plus 1 times x plus 2. Because our two numbers, again, were 1 and 2, which we were looking for back here, D and E. So that means our two numbers are going to be 1 and 2, which end up giving us x plus 1 and x plus 2. I know that's kind of crazy. It's a lot more of an art, like I said, than an algorithm. We're going to have to find things that add to the middle number and multiply to the last one. But I think that's something we can do. So I want to try one more. If we have x squared plus 9x plus 18, then we want to find numbers that will add to this middle one and multiply to this. So the trick is to find numbers that add to the middle and multiply to the end. So if I have numbers that add to 9, there's a whole lot of those. I could do like negative 10 and 19. That's a lot. So I'm going to stick with multiplying to 18 because that gives me a little less options. So numbers that multiply to 18, I could have 1 and 18. I could have 2 and 9. I could have 3 and 6. What else does 18 go into? I think after that it would be back to 6 and 3. So that is all my options there for what go into 18. I add these up. 1 plus 18 would be 19. That's not 9. That makes me sad. 2 plus 9 is 11. That makes me sad. And 3 plus 6 is 9. And 9 is what we wanted these to add to. So what I'm going to end up knowing is that 3 and 6 are my numbers. So I end up with x plus 3 and x plus 6. Ta-da! But sometimes we'll get some things that are a little bit crazier. So for example, if I have a negative c, so c again is coming from our ax squared plus bx plus c. So now we're going to talk about what if this is negative. So if this is negative, we could end up with something that looks like x squared minus 3x. Sorry, plus 3x minus 10. Can't read my own handwriting. That's okay. X squared plus 3x minus 10. So now the question is, what's going to multiply to negative 10? Because again, minus just means plus a negative. So you have negative 10 here, and we're going to do this exactly the way we did it the other way. with a positive number, but now it's negative. So what multiplies to negative 10? Well, I could have negative 1 and 10, or 1 and negative 10. I could have negative 2 and 5, or 2 and negative 5. And that's pretty much all my options. So looking through here, negative 1 plus 10 is going to give me 9. 1 and negative 10 gives me negative 9. Negative 2 and 5 gives me 3. And 3 right here is the one I'm looking for. So because negative 2 and 5 is going to give me positive 3 when I add these up, and I wanted a number that would add to 3, that's what I'm going to use. And I end up with x plus 5 for my positive 5 here, and x minus 2 for my negative 2 here. And just to check that it works, we're going to FOIL this real quick. First is x and x, which gives me x squared. Outer is going to be x and negative 2, which would be minus 2x. Inner is 5 and x, so plus 5x. And last is 5 and negative 2, minus 10. X squared minus 2 plus 5 is going to be plus a 3x minus 10, which is exactly what we started with, which means that we did that correctly. And this right here is going to be my answer. Let's try one more real quick. So what happens if we have a trinomial where we have something, because so far all we've done are trinomials where there's nothing right here. But I said that the form is ax squared plus bx plus c. So let's try it if I have, just for example, let's try this using, trying to find something that would work fairly well. 2x squared minus 14x minus 16. 2x squared minus 14x minus 16. So the first thing I'm going to want to do here is to look at it, and I'm actually going to start by factoring this regularly. So looking at this, I have a 2 and an x squared, and my x squared becomes x and x. 14x, 7 and 2, and 16 is 8 and 2, which is 4 and 2, 2 and 2. 16 takes forever to factor, that's all right. So after I make factor trees of all these, I should be able to find something to pull out, which is going to be this magical 2. So I'm going to pull the 2 out, and I end up with x squared minus 7x minus 8. And just like that, I have something that I can factor the inside of the parentheses and just ignore the 2 for now. So I'm going to ignore the 2, factor what's left inside. And if I factor what's left inside, I need to find two numbers that are going to multiply to negative 8 and add to negative 7. If you guys would like to work that out on your own, please pause it now and go for it. I'm just going to give you guys the answer. Two numbers that multiply to negative 8 and add to negative 7 are going to be negative 8 and 1. So I'm going to end up with x minus 8 and x plus 1. And then I have to remember to bring my 2 down and have a 2 out front. And just like that, I am fully factored, ready to go. So if y'all could try a couple of these, there are a few examples in the lesson practice. There's a lot there, so if you guys can pick 4 of them and do 4 of the lesson practice problems, that would make me feel all warm and fuzzy inside. Friendly reminder, this video is all pink because of the wonderful Abby Cavillo, who is in 8th grade when I'm recording this in 2017. So for posterity, you can find her and blame her if you don't like the pink. In any case, I will see y'all tomorrow and have a blessed day.